Hello, this is Ms. Salter. This is problem number 4 on our limiting reactants practice worksheet number 1. So here we have 4 iron plus 3 oxygen yields 2 iron 3 oxide. We're looking for how much product are we going to get, what is our limiting reactant, and what is our excess reactant, and how much of that excess reactant is left. So, same thing as we normally do. We start this out by figuring out our ratio for our equation. So, that's going to be 4. Here we go. Yep, it's all set up. 4, 2, 3, 2, 2. And we are given 24 moles of Fe iron and 15 moles of oxygen. So, A, how much product are we going to get? So we need to start this off by doing the problem so that we have, we can figure out how much product each of these reactants, if fully used, is going to make. So then we can determine our limiting reactant. So, let me move the screen up here a little bit. Okay, so we're going to start off with our 2 problems. We have 2 reactants, we need 2 problems. Our plan for our first one is moles of iron, 2 moles of iron 3 oxide. And therefore our conversion is going to be 4 moles of iron equals 2 moles of Fe2O3. Then our given and our setup. So our given is 24 moles of iron. We have 1 arrow in our plan, 1 equals in our conversion. We have 1 conversion. So therefore we're going to have 1 fraction. And that's going to be 4 moles of Fe on the bottom and 2 moles of Fe2O3 on the top. So therefore we are going to get a value of 12 moles of Fe2O3. So if we use all of the iron, we will get 12 moles of Fe2O3. Okay, our second problem plan is then our oxygen, moles of oxygen, moles of O2 yielding moles of Fe2O3. Our conversion is going to be 3 moles of O2 equals 2 moles of Fe2O3. And therefore, we can move on to our given and our setup. And I'm going to move this up just a little bit so we can see a little bit more what we're doing. So, given and setup. So we are given, in this problem, 15 moles of O2. We have 1 arrow in our plan, 1 conversion, so we need 1 fraction. We have moles of O2, so we're going to put 3 moles of O2 on the bottom, 2 moles of Fe2O3 on the top, and then that gives us 10 moles of product Fe2O3. So if we use all of our oxygen, we're going to come up with 10 moles of product. So what we want to look at here is the smaller of the two product numbers. Okay? If we use up all of our oxygen, we are going to produce a smaller amount of product because we're going to use it all up. We can't make as much as we can using all of the iron because we just don't have enough oxygen. So therefore, the answer to number A is going to be that we are making 10, let me highlight this, we are making 10 moles of our product Fe2O3 because we have 15 moles of this and we're making that, and then therefore our answer to B, which is what is our limiting reagent or reactant, that is going to be our oxygen. It's going to get totally used up to create that 10 moles of Fe2O3. But then that means then that our excess reactant, or the one that we have some left over, is going to be our iron. Now we need to fix, so actually let me highlight this. Our answer to B is oxygen, limiting reactant. Now we're looking at the rest of our C. So for our reactant that's in the excess, we need to figure out how much we're actually using. So we start with the end in mind. We start with how much product we're going to have. So for this, we're going to start with our plan. Our plan is moles of Fe2O3 equals moles of oxygen. We need to take the amount of product we produce and then figure out how much oxygen we're actually using. Our conversion is going to be, our conversion is going to be 2 moles of Fe2O3 equals 3 moles of O2. Oh, I put the wrong thing there in my plan. I want to have an arrow there just to keep everything consistent. I have 1 arrow in my plan. That means I have 1 conversion. So my given. Now, my given is the amount of product I'm producing. That would be my 10 moles of Fe2O3. My setup is going to be my fraction. I have 1. I'm going with 2 moles of Fe2O3 on the bottom, 3 moles of O2 on the top, and therefore I am left, oh no. Uh-oh. Well, that's a shame. Okay, we gotta back up. My excess reactant is iron, and I went ahead and started doing oxygen. So let's go back here and erase. We have to go back. Sorry about that. Iron. Mole of iron oxide yields moles of iron. 2 moles of iron oxide is 4 moles of iron. And then we have to erase this part. 4 moles of iron. So therefore, I get 20 moles of iron used. Always a good idea to make sure you are writing all of this out. This is why we do this, so we can see where we've made a mistake. If I had all done that in my calculator, I wouldn't know that I was actually using the wrong information. So make sure you are always doing things and writing them down. So that's my amount used. I then have to do my little math problem here. I started with 24 moles of iron. I used up 20 moles of iron. So therefore I have left over 4 moles of iron. And that is a really funky 4 right there. We're going to clean that up a little bit so it looks more like a 4. Okay, so let me highlight this. Let's put it in yellow. So my answer to C, my excess reactant is iron. I double check everything, and I have left over 4 moles of iron. So therefore I have all of my answers to my problem, and that works out pretty well. So that is question number 4 on practice worksheet number 1. I hope that answered any questions you have, and have a good day.